Hello and welcome back to the 6.3 notes. This is part 3. Not sure how many parts we're going to have. We got a lot to talk about. So this one I'm going to make kind of short and just kind of do two practice problems for the disk method. So I do want to write out here the general formula for the disk method. So the disk method. Okay, and that is that the volume is equal to the integral from a to b of pi times big R of x squared dx. Okay, and so what I want to do in these problems is I want to find the volume of the solids generated by revolving the regions bounded by the lines and curves about the x-axis. So that's the important thing, is that we are revolving about the x-axis. So this is our axis of revolution. Okay, axis of revolution. All right, so in order to do these example problems, what I want to do is I want to actually graph these two functions here, and I'm just going to do a quick little sketch of this graph. This is the x-axis, okay, this is the x-axis. All right, it's this line right here, okay, it's a line y equals 0. And then this is a parabola when I have x-intercepts of 0 and 1. Okay, and so I end up getting this region like that, okay? And I want to take this region here and I want to revolve that around the x-axis. And so I use this little notation here to show that I'm revolving that around the x-axis. Now, the thing of it is that I need to take this region and spin it around the axis 360 degrees in order to get the three-dimensional volume that I need. Okay, so the first thing I'm going to do is just kind of show you guys a little animation of what this is going to look like. Now, what I've done is I've taken this this figure. We were looking at the similar graphing, and this is just for modeling purpose. This isn't exact by any means, but just to kind of show you the shape that you're going to get. Now, what I'm going to do is I'm going to take this surface, and I'm going to revolve it around the x-axis here, okay, and see what we get. So let me show you that process. And so I'm using a program that allows me to kind of model the software. So I'm picking the axis here, okay, and then I'm taking this, I'm going to revolve this around 360 degrees. And when I do that, I get this thing that looks kind of like a football, okay? And that's really what it is that we're doing, okay? And we're going to find the volume of this figure here, okay? So that's pretty much what we're going to do. Now, I do want to come back over here and show that. So the big thing that we need is we need to use our formula here, okay? We need to identify what big R of x is. Okay, so what is our radius? So the way that I do it is I draw my slice, okay, and I draw a vertical slice here, and I'm going to call this dx, okay? And so I need to think about this distance, and this is r of x. And so r of x is equal to the distance from the function, any point along this function down to the line y equals 0. Okay, so that is x minus x squared. Okay, and so that radius is going to be the same for any of those points in between 0 and 1. Okay, so that's my big radius. And that's what we need to find. So then the bounds go from 0 to 1, and so we just plug it into our formula. And so we end up getting that the volume is equal to the integral from 0 to 1 of pi times the quantity x minus x squared quantity squared dx. And that's it. okay? And guys, I want you to be able to set these up. Now, yes, you could do this by hand. You could multiply all of this out and evaluate this by hand, but I'm more concerned about you guys being able to draw this picture, find your radius, and then set up your integral, okay? So let's take a look at the next one. So what this says, we want to bound this by the function f of x is equal to x plus 1 quantity squared, the x-axis, and the lines x equals 0 and x equals 2. So I want to do this. I'm going to draw a graph here. We're bounding this between x equals 0 and x equals 2. So I'm kind of just going to get the first quadrant in here. Call this 0, call this, say, 2. And so what I know is that this function here is this parabola that looks like this. Okay, and actually, let me kind of draw it a little bit better. Okay, and so I know that this parabola goes out all the way over here, but I'm really just concerned about the area between 0 and 2 and the x-axis. So let me kind of draw this shape in there like this, and let me kind of shade that this is the region that we want, okay? And that we're going to revolve this around the x-axis, all right? Now let me show you what this is going to look like, okay? It's kind of hard to visualize, so I have a video to show you. But if we take that area and we select it, and if we revolve it around the x-axis, what you end up getting is this kind of like a, I don't know, kind of like a bell-shaped something or other, okay? You get this flat surface on the bottom. It's kind of like a volcano. That's kind of what it looks like. It's a better description. And so, we are calculating the volume of this. We're revolving it around, and that's the volume that we're calculating, okay? So, what I want to do at this point is now go back over here to our picture, and I'm going to draw the slice, okay, because we do have to do the disk method. I'm going to come in here, draw my slice. My thickness is dx, okay? But then the height of that slice is really just my radius, okay? And I'm going to call that r of x. And so r of x is equal to the distance from my function, okay, to my axis of revolution. All right, so, and that's just the function, the quantity, x plus 1 squared, okay? And that's the same for any slice that we do, okay? So now, what I want to do is I want to plug it into my formula. And remember our formula, just real quick, our formula for this is volume is equal to the integral from a to b of pi times r of x squared dx, okay? So for this specific example, all right, the volume is equal to, now we are integrating the area from 0 to 2, okay? So I'm going to write my integral from 0 to 2 of pi times my function r of x, okay? So that's the quantity x plus 1 quantity squared, okay? That's my r of x, and then that's squared dx, okay? And you could simplify this a little bit. You could probably, write this out as volume equals the integral from 0 to 2 of pi times the quantity, just x plus 1 to the 4th dx. That works too. But either one of these is fine. Again, guys, we are more concerned about you setting these up than anything else. So I hope that you were able to get something from these, these two examples. Hopefully these visualizations helped you as well. But that's it for this video, and we're going to go ahead and stop there, and we'll start the next section in the next video. Thanks again.